everyone. So in this video I'm going to talk about finding a polynomial when given points. Now I should say that I'm going to use a graphing calculator that can do matrices here. So if you don't want to learn to do it that way, this is not the way for you. But I'm actually going to use something that's called the n+1 point principle, which is kind of an important little seg into the math mind, I guess. Or you could look at it that way, I suppose. It's just the idea. Oh, I guess it'd be helpful if I wrote that down. Well, not in that color. That is not helpful at all. Let's try this. n+1 point principle. And it's the idea that if you have 2 points, no matter what, as long as they're in the same plane, as long as they're in, the same existence, not the same plane, they can be in any, they'll make their own plane. But if you have 2 points, it'll be a line. This is all assuming, by the way, that these points meet the requirement for the vertical line test. It passes a vertical line test, which is to say it doesn't, curve back in over itself. This would not, the n+1 point principle won't work then. But if you have 2 lines, or 2 dots, or points as they were, you'll have an x. So the x is of 1. If I have 3, can't talk today. If I have 3 points, unless they're on the same line, and I'll make them more dramatic, unless they're on the same line, I'm going to have some bit of quadratic structure. So if you have 3 points, x squared. If you have 4, it's a bit of a x to the third power, even though I drew them really close together and I wanted to have it look a little bit more like this. But anyway, if you have it, you're dealing with the idea of 4 points will give you sort of an x to the third. So the idea behind it is that if you have this number of points, the n would be the degree, by the way. So whatever the degree is plus, you'd have one more point. So if I have 1, 2, 3, 4 points here, I can say that this graph is going to be x to the third power. That's going to be the highest degree on my leading term. So let me erase all this out. Now, what do you do with that? Well, the idea behind it, now that we know that it's cubic, is that we need to write out the standard form of a cubic. So we'll do y is equal to x to the third, and we're going to put an a in front of it to cover for the coefficient, plus b x squared plus c x plus d. That's a generic form of equation. Where we go from this is I'm actually going to make what would be rows, essentially, in a matrix by plugging in these values to the equation. So for the yellow one, I'm going to end up doing, I'm actually going to move the y equals to the other side, just so it sets up the way it's supposed to set up when I turn it into a matrix. So this would be equals y. So for this one, I'm going to do -3 in place of x. So a times -3 to the third plus b times -3 squared plus c times -3 plus 1d is equal to my y value of -53. Now, what that goes into, or what it becomes anyway, is I'll do -3 to the third power and get -27a. And then -3 squared, of course, is 9. Make sure you put the -3 in parentheses. I don't know why I put the square inside, but it should be on the outside. Don't do what I did, like this. You'll end up getting plus 9b, and then -3c plus 1d is equal to -53. Now, from here, I'm actually going to go through and write out the other 3 and move this one up a little bit. So I'm going to pause the video so you don't have to sit here and watch me do it, because it'll take a little bit of time. But essentially, I'm going to take this -2 and plug it in for x and set it equal to -18. And then I'm going to do the same thing for the +2, plug it in for x and set it equal to 2, and the 3 and plug it in for x and then put the 7 for the y. So in just a second I'll be back. You probably won't even notice any real-time moving, and then I'll be back and explain where to go from here. All right, so now that I have all of these here and ready to go, I have them organized in a nice set fashion. It'll look in standard form. So really, so far, what we've done is figured out that if you have however many number of points that you have, you subtract 1, and that will tell you the overall shape of your polynomial. So if you have 5 points, that means you can have 4. X to the fourth would be the most. Then you need to write the standard form as it is of that. So y equals x to the fourth plus, or so it'd be ax to the fourth plus bx to the third plus cx squared, that whole thing. Work those out. And then what you'll do is plug your x values in and set them, and then plug your y values in as well. Substitute, I should say. Plug in is an evil word now. Substitute your x values and your y's. Make sure you put any negatives in parentheses to give you that. And then you'll have this setup. What we're going to do is actually convert all of this into a nice matrix. So when I have these, it's going to look like negative. It's not the best color for this background. Just use this and be lazy. Negative 27, 9, negative 3, 1, negative 53. That's our first row. And then in the next one, I'll do a negative 8, 4, negative 2, 1, negative 18, 8, 4, 2, 1, and 2. The big key here is to make sure that for your final value, if it's D or whatever letter it happens to be, you put a 1 there, because if you don't, it will drop off. The system won't work. You can't do what's called reduced row echelon form. It won't evaluate it properly. So I have it like this. I'm actually going to bring up my calculator now. This is the matrix form of what it's going to look like. So I'd go over to wherever your matrix thing is. It's mine on the TI-84 Plus is second, and then it's like the fourth button down. It's the x to negative 1 button. So hit edit, and then I'll just go ahead and punch it all in, and it should match. And you can, once you've finished typing it in, you can check your rows. This is a 4x5 matrix in this case. You always name matrices by their number of rows. So negative 27, 8, 8, and 27 looks good. This column looks exactly like I want it to. This one does as well. So does this one. And then finally, this one looks pretty good too. So now that I have that, I can quit out. You did all that work typing it in, and now you have to quit. But we're going to use it now. So second matrix, and I'm going to go over to the math menu. Now I need to go down to reduced row echelon form. Right here, RREF. Don't just do reduced. Don't do reduce echelon form. You need to reduce row echelon form. So RREF. Make sure. I think it's B in mine anyway. So I'll hit that. And then I want to hit second matrix again and pick the one I want to apply that to. I want to run it with matrix A, whatever you named it. And hit enter. And you will get all this stuff. These ones and zeros in the first 4 columns represent sort of like a light switch. 1 means it's turned on, and 0 means it's turned off. So in the first column, the only one that's turned on is this top one here, which means that's the value of the term for A. So my A term is going to be 1. My B term is going to be negative 3 because the second row is the only one turned on. Third one, this is my C term, and finally my D term. So what I'm going to do is turn that into, and this will probably drop the calculator up a few times, so my apologies for that. So I use the standard form again. So y is equal to, and in the first case I want to look and see that it's 1. So that would be 1x to the third power. And for the second set, it would be negative 3, so minus 3x squared. So basically I'm just putting them as coefficients on my variables. And then plus 1 x plus 4, I think. Yes, just like that. So I'll go back and organize this a little better. Y is equal to x to the third minus 3x squared plus 1x plus 4. That's my polynomial. Can I check my answer? Absolutely. Before I talk about that, let me go back through sort of the steps again. If you have your points, you need to figure out what type of polynomial you're dealing with. So take the number of points, subtract 1, and use the standard form of that to set up these types of equations while plugging in the x values equal the matching y values. From there, once you have it all worked out, and in this form, convert it into matrix form, and then we're going to punch it in probably to a calculator to run a reduced row echelon form and in the calculator, and then it will give you the values that are the new a, b, c, and d, or whatever you happen to have in your polynomial. It may be a lot more letters for your final answer. So can we check? Yes. So let's do that. So where do we go? We will go to the list, wherever you enter in data. Put your x's on the left and your matching y values on the right. Make sure they're matching. If they're not, it won't give you the right answer. So from here, I'm going to quit out. Then I'm going to go back to my stat button. That's what I use. Go over to calculations. And since we know that it's x to the third power, we're going to do a cubic regression. There it is right there. Make sure that you're picking from the correct lists. My L1 was the row or the column that I had x's, and y was L2. So I hit enter, and it will give me this result. Also, as an added bonus, it tells me what the a, b, c, and d are. So 1, -3, 1, and 4. So if you do that, you can check to make sure you have the correct answer, and that's all that you need to do.